Hello, my name is Bobby Bramlett. I'm a field applications engineer with Analog Devices, and we're at APEC in San Antonio, where I'm showing two of our upcoming power system management devices developed by the Power by Linear group at Analog Devices. The first part we're showing is a 60-volt input, 2-channel PSM part that has digital telemetry for doing monitoring voltage, current, temperature faults. You can also digitally program the voltage, the current limits, soft start, sequencing, margining, under voltage and over voltage thresholds, along with programmable loop compensation. It has a built-in EEPROM that has a capability of storing into non-volatile memory any faults that happen in the system. The new part that we're releasing is going to have adjustable gate drive so that you have flexibility in the FETs that you choose for your high input voltages, and an ability to program a voltage out of up to 38 volts. We've also created a low minimum on time with this part of 45 nanoseconds to allow for a high step down ratio, and is pin compatible with our existing LTC 3886 with the benefit of the lower minimum on time and the higher V out capability. The second part that we're showing here is our 8-phase DR MOS driver chip. This part will drive up to 8 DR MOS parts. It has 2 outputs, and you can flexibly program the phases between those 2 outputs. You can have 4 phases on one side, 4 phases on the other. You can do 3 and 5. You can go up to 8 phases for a single output and actually hook it up with a secondary chip to get 16 channels of output. Benefits of this part is it uses the internal current sense of the DR MOS parts, so you need no additional current sensing elements in the loop, which gives you a higher efficiency. We've also added, in addition to the I2C standard PM bus, a high-speed SPI bus that allows you to do a rapid V out adjustment. That can help you in systems where you need to margin up quickly and back down for testing out ICs. Another feature that we've added into this is a patent-pending load step emulation. With high current outputs, trying to hook up a load to test a 100 amp load step can be difficult, and sometimes you don't have the equipment. So we can emulate that with the board with no additional hardware needed, and I'm going to demonstrate that now. So in our PM bus window, we can go up and we can program a load step, and we can do 10 amps, 20 amps, or 30 amps per phase. So we're going to do a 10 amp per phase load step here. I'm going to update that to the system, and you'll see that we get a transient response based on that load step. Unfortunately, this is not an optimum load step, but that highlights another feature of these controllers. Although these are analog control loops, we give the ability to tweak some of the analog aspects of that control loop. So inside the device, we can actually change the gain of the air amplifier, and we can also adjust an internal resistor to adjust where the zero in the system is. So I will turn off the load step first, and I will lower our transconductance gain in the air amplifier, and then we will restep the load, and you'll see that we get a much better response based on the caps that we have on the board. So this concludes my demonstration of these two parts. For more information, please go to www.analog.com.